The title is Innovative UHPC Mixing and Placing Techniques for the Repair of 3 Illinois Bridges. My name is Michael McDonagh. I'm the Vice President for Engineering and Projects with Steel-Like. We are a commercial supplier of UHPC. All right, just quick agenda. I'm going to do a brief introduction to UHPC, or ultra high performance concrete. I'll do an overview of the project, the repair approach, and then before I can really talk about the innovative construction practices, I first have to give an introduction to traditional UHPC construction practices so you can see the difference, and then some lessons learned, and I'll wrap up with a summary. So UHPC is ultra high performance concrete. It is a valuable tool for infrastructure durability. And for those that may not yet be familiar with it, it is a cementitious fiber reinforced composite. The largest particle is fine sand, typically less than ½ of a millimeter in diameter. It's highly flowable and hence self-consolidating, has a very low water to cementitious materials ratio. A UHPC class material is typically limited to a 0.25 ratio versus 0.4 to 0.6 for conventional concretes. A lot of the UHPCs, including Steel-Like, has an even lower ratio, around 0.18, 0.19, and it has advantageous mechanical and durability properties, such as a very high compressive strength at 28 days of around 22,000 psi versus, say, 4,000 psi for conventional concrete. It has significant tensile strength, and that will depend on how much steel fiber that you put in it, but a typical benchmark is a minimum tensile strength of 750 psi. It bonds extremely well to conventional concrete. In most applications, the substrate concrete will fail before the interface will fail if you're doing pull-off testing. And thanks to the steel fiber, it also has strain hardening behavior, property normally associated with metals, but it can undergo strain hardening up to a strain around 0.0035 microstrains in tension. Durability is where UHPC really shines. There's a number of ways to measure the durability of cementitious products. One is a rapid chloride test. UHPC class material is considered to have a maximum coulombs of 250. Steel-Like and other products, some of them go as low as 50 coulombs versus 1,000 or more for conventional concretes. Or if you look at a chloride ion diffusion coefficient using some rounded numbers, we're looking at about 10 times the smaller coefficient versus high performance concrete, and about 100 times smaller versus conventional concrete. And this is not just all theory. This has actually been proven in the field by a project where samples of UHPC were left at mean tide in northern Maine off the coast for 10 years and longer. And UHPC samples that were in this environment after 10 years and 15 years, they were pulled out. Rebar with only 3/8 inch cover was extracted, and the rebar showed no signs of corrosion. All right, so now moving on to the Illinois project. As the title said, it involved repairing 3 bridges. These are all located in Kane County, Illinois, about 50 miles west of Chicago, and they're all within about 15 miles of each other. 2 of the bridges were side-by-side box beam bridges with failing connections. The keyways were failing, resulting in reflective cracking and deterioration, and one had a deteriorating deck. So the Scott Road Bridge, shown in this photo, this is one of the side-by-side box beams, about 75 feet long, 30 feet wide. And you can see in the left lane in the photo, you can already see some reflective cracking coming up through the asphalt overlay, indicating that the box beam grouted keyways had failed. The Hughes Road Bridge is a similar bridge, similar condition, except it has a concrete, or had a concrete overlay. And in the little zoom in photo in the top corner, you can see some of that reflective cracking appearing in the overlay. So once again, grouted keyways were failing, which was leading to advanced deterioration of the box beams below. The third bridge was Granite Road Bridge. It's 140 feet long, 3 spans, I believe, about 50 feet wide. with a concrete deck, and the deck was experiencing cracking and showing signs of distress. So the King County Department of Transportation, to repair the two box beam bridges, Scott and Hughes Road, they opted to use ultra high performance concrete. And their approach was to first remove the overlays and then excavate and widen the keyways so that the rebar inside the box beams was exposed. And then, and also creating sort of a V shape to the best of contractor's ability within those widened keyways. And of course, you can see in the photo here, the keyway widening being complete. And then once that was done, rebar stirrups were placed across the new widened keyways, which you can kind of see in the lower left and in the bigger photo, in order to link the rebar across the connection. And then the connections were filled with steel-like UHPC. So, and these two bridges, in fact, represented only the third and fourth applications of UHPC for box beam connection repair in North America. Now, the Granite Road Bridge, which had the distressed deck, the first step to rehabilitate the deck was to hydro demolition the top surface of the deck to remove dirts and soils, soiled concrete, and create a roughened surface, essentially a clean roughened surface. And then quite simply put down 1.5 inches of UHPC. So in this case, the UHPC is waterproofing the deck. And although not the intent, it's probably also adding a little bit of strength to the deck. So, and with its extremely high bond, it's expected to last a very long time, probably 50 years or more, and thus greatly extending the service life of the bridge. So I came here really to talk about innovative construction practices. And in order to do that, first you need to understand how UHPC has traditionally been placed. And it's been around for about 15 to 20 years. UHPC has been used in US transportation infrastructure. And for the vast majority of that time, it's been done the same way. So if we're talking a connection project, whether it's a new one or a rehabilitation like the Scott and Hughes Road bridges, typically the contractors would have to rent specialty mixers from the UHPC supplier. Very commonly, you'll see mixers such as the type in the photo here, vertical shaft high shear mixers. And they come in different sizes, but the largest can only mix 0.6 cubic yards. And they sometimes break down, and given their small capacity, typically multiple mixers are required, at least a minimum of 2. And the contractor must also rent relatively large generators to power these mixers. And in this photo, you can see dry UHPC mix being loaded into a mixer. So I kind of skipped a step here, but obviously once the UHPC is mixed, you will place it in the connections. And this photo shows a deck panel connection job. But whether it's deck panels or side-by-side box beams, typically your top surface is not level. So therefore, you would typically top form in order to keep the UHPC from flowing out the lower end because of its self-consolidating nature. And then once you top form, now you are creating the risk of trapping air that may be escaping. So most agencies then require that the connections be overfilled, which you can kind of see in his photos, so that any air that gets trapped under the form is above the level of the deck, and then that will get grinded away, leaving you a flush surface. Now for UHPC overlays, overlays have only been around in the US using UHPC for about five years. And during that time, it's, again, pretty much the same practices. So similar to joint fills, the contractor must rent specialty mixers from the UHPC supplier. Now, because of the higher volumes involved, typically they use larger volume mixers, horizontal shaft, high shear mixers, which max out at around 1.4 cubic yards capacity. Again, typically multiple mixers, and the contractor must provide rather large generators. In fact, you can see one in the left foreground of this photo. So then the UHPC would be discharged from the mixers into concrete buggies or maybe wheelbarrows for smaller jobs, and moved out to the screed location on the bridge deck and pour it onto the deck. And then of course, then the screed will move across and screed the UHPC off. Once the UHPC has been screeded, curing compound is typically put down, followed by plastic sheeting to prevent moisture loss. And the plastic sheeting needs to be held down, and that has to be carefully done in the early days or early hours when the UHPC is still soft. Contractors will often spray water on the sheeting until it hardens up, and then come back with plywood or 2x4s, such as you see in this photo here. You also see in this photo, wind is blowing underneath the plastic sheeting, which creates issues. If too much wind blows under the sheeting, well, now you're kind of rendering it ineffective in terms of preventing moisture loss. It can also blow your sheeting into live traffic if you have a staged construction site. And then there's also a risk of it leaving impressions in the UHPC. In this photo here, you can see a number of deep impressions that exist even after the UHPC overlay was grinded and grooved. And finally, there's a number of documented cases of workers who venture out onto the UHPC, probably to adjust the hold downs if the wind kicked up, thinking it could hold their weight, and then they end up leaving footprints. So now I'm going to talk about some new innovative practices that Steel Like has helped contractors develop for mixing and placing UHPC. And really the goal here, Steel Like's goal is to make UHPC more user-friendly and more accessible. So for the Scott and Hughes Road box beam keyway repair projects, the Steel Like UHPC was mixed in a locally available standard ready mix truck. And Steel Like is the only commercial UHP supplier that can and does do this on a regular basis and successfully. For this project, up to 6 cubic yards were mixed per batch, although we do have the capability to go up to 7 cubic yards per batch. So with these very large volumes, essentially the contractor can discharge it as fast as they're able to place it. By renting a ready mix truck locally, you're avoiding the shipping of specialty mixers. Because ready mix trucks are very robust equipment, you typically don't need to worry about multiple mixers. And even so, if one breaks down, you can usually get another truck with a quick phone call. And you don't need generators because the trucks are self-powered.
You have 2 minutes left, Michael.
Seriously, okay. I need to accelerate myself here. So another advantage that was used on the mixing was the material was actually mixed at one bridge and driven 15 miles to another bridge, and was kept alive for more than 1.5 hours, saving the wasting of a batch and the need to mix an additional batch. Another advantage that was used for the top forms, or excuse me, for the joint projects, was eliminating top forms. Steel Like has developed a process that constructors have successfully used where they can eliminate the top forms. Hence, you eliminate the risk of trapping air. And you also eliminate the need to overfill. And the ultimate goal here is to eliminate grinding, which was the case for these projects. Now, in areas where there was differential deflection, maybe between beams, or the cross slope was too high, a edge form was put down at the top. But because these bridges had overlays, the owner saw that the overfill was very minimal, and the owner accepted not grinding, saving the contractor significant time. For the Granite Road overlay, the UHPC was also mixed in a ready mix truck, which provided a major advantage besides the volume and eliminating of specialty mixers, and that was the ability to discharge directly from the ready mix truck onto the bridge deck. So you're eliminating concrete buggies, you're eliminating the laborers to move those buggies, and you're eliminating the waste that gets generated every time you transfer material from one vessel to another. This accelerated the placement and also has an added advantage of being similar to ready-mix concrete discharge. It's just a close-up photo. So, and this is the first time this practice has been done with UHPC. Furthermore, Steel Like UHPC can be cured using only curing compound. That its unique behavior allows it to restrict water loss by itself only with the help of curing compound. So sheeting is not needed, eliminating all the risks of it, which I identified previously. And then just to show the completion of the job, as with all UHPC overlays, the final surface was grinded to provide skid resistance. So some lessons learned, mock-ups are essential. I'm not going to go into detail of that because of the time involved, or limited time. And contractors should follow past successful practices. Many contractors think, well, if they know concrete, they know UHPC. That's not the case. They need to listen to the UHPC suppliers. So in summary, steel like UHPC was mixed in standard locally available ready mix trucks, which was an innovative mixing technique with large batch sizes, and also was able to transfer material from one bridge to another, eliminating a lot of material waste. For placement techniques on the connection projects, top forming was eliminating the trapping of air, and the ultimate goal was eliminating grinding, saving time and cost. And for the overlay project, mixing UHPC in a ready mix truck, again, brought advantage of large material production, but more importantly, the ability to discharge directly from the mixer, which was the truck, to the deck, accelerating the work and reducing labor and waste. And finally, curing without plastic sheeting, which eliminates the risks that plastic sheeting presents to a UHPC overlay. This was a contractor's first time working with UHPC, which did create some challenges. However, with guidance that Steelite shared from other contractors' experiences, the project was ultimately successful. With the unique innovations for mixing and placing, helping to accelerate portions of the job and reducing waste and the contractor's costs. All right, that's all I have, and I thank you for your attention. And I guess we probably don't have time for questions, but if so, I'd be happy to take any.
Thank you, Michael. So it's a nice talk. We got 2 questions here. So how much more expensive is UHPC compared to normal concrete? And does the industry consider using recycled materials like fibers, aggregates to reduce the costs?
Okay, well, cost compared to conventional concrete, it is much higher, but you have to bear in mind how the material is being used. Just on a pure cost dollars per cubic yard basis, it's approximately 10 times more expensive. But you could make an 8-inch thick cast and place deck out of UHPC, and it would be the world's most wonderful deck, but it wouldn't be a good use of your money. In that case, you'd be much better off making it out of conventional concrete with a UHPC overlay. So in many respects, UHPC is more comparable to epoxies and specialty grouts and things like that in terms of how you use it, but it does have compatibility with concrete being a cementitious material itself. So yeah, so it's a lot more, but you have to use it properly. And when you do that, you can actually make it cost effective. Now, the second question, as far as recycled materials, I can't speak for other suppliers, but I know at least Steel Like UHPC does already contain a significant amount of post-consumer or probably post-industrial waste that is recycled. Just thinking out loud here, like blast furnace slag, just as an example of an industrial byproduct that is used in concrete. So things of that nature are already a significant component of Steel Like UHPC and probably other UHPCs. These steel fibers, to my knowledge, they are not made of recycled material, but I don't see any reason why they could not be. The steel is a highly cyclical material in terms of its recyclability. So I hope I've adequately addressed that question as well.